Hey, everybody, we've done it. We had to reset everything. Took about 5-6 minutes there. Sorry about that. I went to go to it, so the Kahoot code's right there. I clicked go live, and then I was like, hey, everyone, how are we doing? Let's get ready to start the Kahoot right here. And no one was talking to me. And I was like, hey, how's everyone doing? And then no one was talking to me. You see, now people hopefully can hear and see me. Can anyone hear me? Can anyone see me? If this, yay, someone's joined the Kahoot, that means we're here. You should have seen it. I was like, after like 30 seconds, I was like, no one's here. And I think what it is they updated Streamlabs, and somehow the connections, like, it wouldn't stream to the stream. It wouldn't stream to the stream. It's a problem. If you can't stream to the stream, you can't stream. That's what they say. But I am glad it is now working. I just did a full reset of the computer and was like, well, let's try resetting everything. And I was like, well, let's try making a go live stream. So I clicked the go live button. So I think it labeled everything properly. I think it did. Look at this. We already got 14 people in here. You can hear me. Awesome, Nikki. Good to see you, Dan. Good to see you, Nikki. Good to see Samantha, Ashna, Andrew, Victoria, Daniel, everybody here. Clarified, Tyler. We'll get started here in like 2 minutes. 2-minute countdown. Set a timer for 2 minutes.
Okay, 2 minutes and counting.
Here we go. 2 minutes till start. Is everyone ready for a good weekend? We're playing Alabama this weekend, right? I'm scared. Scared Alabama's going to win. I don't think they'll win. I'm just scared they might win. Yes. Excited for the weekend. It is the weekend. Next week is Halloween. Remember, our class is going to get a visit. Well, oh, wait. Come to office hours on Thursday. Thursday's a special visit. Because he only appears on Thursday. You still want that plane ticket to go to Cookout for the Mario Party? For the Mario... You know what's really fun is Mario Party. Mario Party with like 4 people. It's a lot of fun. Can you play more than 4 people at Mario Party? Probably the newer ones you can. So like Mario Party 10. Is Mario Party 11 out? Mario Party, the one where you have to wind it up and you hurt your hand. Who knows what I'm talking about? The mech racer or you have to... Who knows what I'm talking about? Someone knows what I'm talking about. We're talking some N64 Mario Party here. When you have to wind up the Shy Guy. Single person. Ever play that one? And you just hurt your palms. You just winding it up. No one knows. Not a single person's played N64 Mario Party. It's sad. Some of the best Mario Parties out there. See, now we have Among Us and everything. Among Us is a great game. I was watching someone playing it last night in the background. Who all is dressing up for Halloween? Oh, you got dressed up for Halloween. I'm dressing up for Halloween. Well, pre-Halloween. Because not going out for Halloween, so. But I'm going to dress up for Halloween. It's fun. It's the one of the year you get to do some craziness. Get to do everything. If you don't know, if we beat Alabama on Saturday, Mario Party at Cookout, everyone's invited. Yeah, that's awesome. What are you going to dress up as? What are you going to dress up as? You should appear in your Zoom classes dressed up for the weekend. We're starting here in just a second. We're going to review the practice exam on Monday. So I've got some videos posted doing the practice test. Oh, it's time. I'll answer this one, then stop timer. So I've got videos going over the practice test. And so I can always answer any questions. So Monday, I might focus on kind of coming up with new questions. And I'm going to take a look at the test material. And so Monday during class, I'm going to be basically coming up with questions that are basically related to the test. I will be Heath Ledger's Joker. Oh, someone might try to give you a run for their money. Maybe someone else has those plans too. Maybe Thursday you should come visit class. They'll have to send me a picture, Daniel, see how it goes. Be an astronaut. Dan and Brian are going to maybe have similar plans. With that, it is time for the Kahoot. Crown Tundra, what is that? You can make your own costume at college. We're going to start this Kahoot in 3, 2, 1. Let's Kahoot. So it's all over conference roles. Where's that block thing? Really? Conference roles are taken from a what? Are made from taking a what? I need to get this to go away. Where is my white on there? There it is. It's like a lot of things were reset. So what do we make conference roles from? Now, it's not the center of a conference roll, but conference roles are made from a what? From taking a what? You can be Brian Stevens for Halloween. Grow your hair out long. Get older. Oh my gosh. Excellent work. Confidence intervals are made from a sample. What do we get? What is the center of the confidence interval? What is the center of the confidence interval? The center of a confidence interval is the what? So the confidence interval is made from a sample. A lot of great answers right there. The confidence interval is made from a sample. We collect a sample, and p hat can be at the center. P hat is a what? You are correct, Samantha. P hat is at the center of the confidence interval. No, that's a good answer. P hat can be at the center of a confidence interval, and p hat is a what? You are correct. The center of a confidence interval will always have a what? P hat is a statistic. So the center of a confidence interval is always the estimate of the what? The confidence interval is made from a sample. At the center of it is a statistic like p hat, which estimates the parameter for the population. This is going to be helpful for the next one. Let's see if we can get even more people getting it correct for the next one. But so p hat is being made to estimate what? What is p hat being made to estimate? P hat is being made to estimate what? P hat is being made to estimate what? P hat tries to estimate this. We make a confidence interval from the sample, which we can collect and find something like p hat, which is a statistic, and then we will try to estimate what? P hat is trying to estimate what? P hat is an estimate of... P hat estimates P exactly, which is the parameter. P hat tries to estimate P, which is the parameter, which is the truth for the population. Excellent work right there. Oh no, I'm blocking the way. Power Rabbit. Is that Morty? Morty, are you in the game? I should go check on Morty. If I could pick up Morty, I'd pick him up and I'd bring him in here and I'd like hold up Morty and I'd be like, this is Morty. But Power Rabbit, you are number 1. Tropical Tiger, that's some alliteration right there. Tropical Tiger, let's see this happen. Tropical Tiger, you're my number 2. Let's see who wins with the next question. Confidence rolls estimate a truth for a what? Confidence rolls are trying to estimate the truth for a what? They got new music in this. This is totally new music. What are confidence rolls trying to estimate truth for? A bunch of people clicking in. Oh, it's because I clicked 20. Oh, no. They're trying to estimate a truth for a population. The parameter is what they're trying to estimate. Sorry, that was a little bit confusing right there. I should have maybe clicked both of them. But they're trying to estimate a truth for a population. And don't be tricked by these. A lot of these are on the Canvas content quiz. So the population is taken from a what? It's taken from a what? A confidence roll is taken from a what? Is constructed from a what? They're constructed from a what? Confidence rolls are constructed from a what? A sample to estimate a truth for a what? They're taken from a sample to estimate a truth for a population. The truth they are trying to estimate is the parameter. So what is the truth the confidence roll is trying to estimate would be the parameter. What are they estimating the truth for is the population. So the population is the group they're trying to estimate for. The parameter is the thing they're trying to estimate for that population. It's a little bit confusing. Even when I was writing this, I was like, oh no, it's going to trick people. And that's why I hopefully tried to allude to the answer as we explained through the next one. But this is on the Canvas content quiz. Just giving some hints right here so people know. Be like, oh, wait a minute, when I do the Canvas content quiz, maybe I go back and look and be like, we got this answer right here. We can do this. Oh no, I didn't mean to shatter any scores. I didn't mean to shatter any hopes and dreams. Power Rabbit, no! Why did I do that? Why did I write that question? Power Rabbit, you can still do this. You can still do this, Power Rabbit. Let's see, with the next question right here, who's going to win? Question number 3. The success-failure condition requires this many successes. The success-failure condition requires this many successes. Why did I do so many 20-second questions? You have to click to 30. Oh, we tricked a bunch of people. So there are 3 conditions. Condition number 1. No, that's all right, Power Rabbit. You're all right. Condition number 1. What is condition number 1? Condition number 1 is what? Random. You know it right there. It's random. Condition number 1 means we randomly select things. Condition number 2. What's condition number 2? What is always condition number 2? Condition number 2 is what? 10%. And what does that mean? So this is a different 10%, right? I mean, it's 10%, but it's not the answer to the success failure. 10% means we do what? We select what? And great job, everybody. Sometimes this is more active than class can be at times. I'm so proud of everybody being here, working hard, practicing the material. We get less than 10% of the population in our sample. So if you're wondering what this means, if we're sampling UT students and there's 30,000 UT students, we can't sample more than 3,000. So you have to sample less than 10%. So less than 10% of the population is in your sample. It helps sometimes to know the size of the population, i.e. maybe the population is U.S. citizens or like people in the U.S. And so there's 300,000 or so, 300 million, oh my gosh, 300 million. And so we can't sample more than 30 million. So the last condition right here, before we get to it, what do we do? Before we get to this last condition, what do? We have to do what? I want to see in the chat. I want to see that chat go crazy with this for a moment right here. What do we do before we say condition number 3? We pause. Because there's going to be a different condition based on what we're doing. So the success failure condition is the 3rd condition. There is no order to them, but it just helps to put them in order. And the success failure condition states that we need at least 10 successes and 10 failures. So I find that this condition is one that people often have a little trouble with. There are some more review questions coming up on it later right here. So we need at least 10 successes, at least 10 failures. What this would mean is if you took a sample of 100 UT students, let's do 200. You take a sample of 200 UT students, and in that sample, there are 50 of them that like Cookout. Should be more than that. 50 of them that say Cookout's their favorite restaurant. So what would NP be right there? So you have X equals to 50. n equals to 200, p hat equals to 0.25, and then x is also, or np is also, np hat, which is the amount of successes, is 50, and then nq hat, which is the amount of failures, is 150. So when you do a confidence interval, it's the amount of successes you have, i.e. x. But what if we said this? What if we said you take a sample of UT students, you take 300 students, and 3% of them say that McDonald's is their favorite restaurant? Would you have enough successes there? So you take a sample of 300 UT students, and 3% of them say that McDonald's is their favorite restaurant. Sample of 300 students, and 3% say that McDonald's is their favorite restaurant. No, you would not. Because how many successes would you have? You would have how many successes? We do not exactly, Victoria. Great job, Victoria. Another 100 points. You'd have 9 successes, and then you'd have 291 failures because they don't think McDonald's is a great restaurant. Sorry. McDonald's is awesome. I'll happily eat some McDonald's. Let's do this right here. They got spicy chicken nuggets, I heard someone talking about that. Ooh, smooth crab. Just going right in there. So creative dragon, I love it. Fearless frog. I still want to see the hint. Next question. Let's continue on. Do some more review right here. I think McDonald's is totally worth it. Which of the following changes the confidence of an interval? Which of the following changes the confidence of an interval? Oh, man. Are you being mean about a 20 piece right there, Tyler? You get a 20 piece with like 4 dipping sauces, because you know you're just going to go crazy on the dip. It's like barbecue dipping sauce, or like sriracha, or you got like there's spicy one or something. I don't know. I just need some barbecue. Ooh, so we got some misses here. That's all right. That's all right. I think I have a Word document open. Let's sit. Oh, you're saying the new spicy ones. Sweet and sour. That's what I was looking for, Sterling, right there, 100 points. Sweet and sour is what I was thinking about. I was thinking like sriracha, and I was like, I know they got something like sweet and sour is where it's at. Sterling knows what's up. Get a spicy nugget with some sweet and sour. Woo! That'd be awesome. That's what we all should have. We all should be so lucky. So when you build a confidence interval, what? Rainbow pen. I did not ask for rainbow pen. So when you build a Mulan Szechuan sauce, oh my God. Why you do this to me? Andrew coming here. 1,000 points, Andrew. Spicy buffalo. Oh, that's really good too. That is really good. What's up, Clay? So good to see you. So we see right here this Z. Why does this Z have a star? What? Oh, I'm so sorry, Andrew. I'm probably in the same boat. What does this star mean right here? What does this star mean? What does this star mean? So we could make a confidence right here. It can be any value. Exactly. You pick the Z-score. So you pick the Z-score right here. Can anyone tell me what % confidence interval I'm building right now? Can anyone tell me this is just some made-up problem where we sampled and 10% had it? But what about the homework question that asks, what n would have to be decreased to confidence interval by half? That's a tricky one, and you times it by 4. So if you're wondering about that, I can show that here I'll show that here in Victoria in 2 seconds. You choose the Z-score, you choose the confidence. 95%, yeah, 95%, great job. This is a 95% confidence interval. Does anyone know what % confidence interval this would be? Who knows what % confidence interval this would be? About what % confidence interval would that be? Just think of it as a Z-score. Just think of it as a Z-score, and the Z-score controls the % confidence. So 68, you got it. 68% confidence because of the empirical rule. So what % confidence interval would this be? What % confidence interval would that Z-score be? So remember, it's just a Z-score, 99.7. Exactly. And so the reason it's 1.96 is we're doing a more exact Z-score. 2.00 is technically a 95.45% confidence interval. So it's just more exact to do 1.96, very famous number in statistics. So the Z-score right here controls the % confidence, and 1.96, classic Z-score. And just so we can mention it, do I have it up? I'm going to bring it up here real quick. The David M. Lane applet. If you are wondering, many people have wondered, how do we get those Z-scores? Well, one, you can memorize them. You don't have to. But if you click here, and then you go to between, and then you go and put in your number here and have the normal curve, the standard normal, you can get every single Z-score. Now, a really important question that was asked, if we have to get half of the standard deviation, here's what we can do. Check this out. You ready? So the margin of error is going to be the following. Z star square root p hat q hat over n. And I think the question is asked half the standard error. I don't love this question. I don't want it on the test. It's just an algebra question. So if you want to make this half right here, if you want to do this 1/2 right here, Andrew is an all-star. He's a rock star right there. If you want to make this 1/2 right here, half of what it was, then what would you have to do? Well, you can't multiply these two as they are, but you could do this. You could turn 1 into 1 squared, but square root it, and you could do 2 squared, but square root it. Well, that leaves 1 still as 1, but this becomes 4. So if you want half of the standard error, you would simply go right here and take what of a sample size. If you want half the standard error, you would take what of a sample size. So if you saw how we kind of fixed it so we could join them together, if you want half the standard error, you would need to take how much of a sample size? Love it. Andrew's going to take everything over. You would take 4 times the sample size. So that's kind of a quick solve on that problem right there. And great work. A lot of great grades. It's a crazy semester. I want to say thank you so much because 201 is doing very well. Students are doing great in class. Let's see how everyone's doing right here. This leaderboard is insane, guys and gals. This is insane. Power Rabbit is back. Fearless Frog taking the lead right there. Who's going to win? Let's find out. Which of the following is the sample proportion? Notation quiz. The sample proportion is which one? Notation quiz. What is the sample proportion? Note-taking quiz. Note-taking quiz. Do you know? P and Q are complements. P hat and Q hat are complements. Complement means that they both add up to 1. So if P is 0.3, Q is 0.7. And a lot of people got it. But remember, this is the what? P hat right here is the what? It's the sample proportion. And then P is the what? P is the what? P hat right here is the sample proportion. It usually looks like P hat. We were showing it just a second ago. I just can't put those characters in there. It looks like P hat. That is P hat. P hat, and then P is the parameter, which is the truth. So P is the true proportion, the parameter of interest, what we're trying to measure. So we use P hat to estimate P. And so good job right there. Make sure to review this. Have these in your notes. Remember, this is like good practice right here. And then Q is the what? The complement of P. And Q hat is the complement of P hat. Is the leaderboard going to go crazy again? This is a pretty Power Rabbit. I told you, I had faith Power Rabbit the whole time. You got this. Power Rabbit, let's do this. Smooth Crab and Fearless Frog, so close. My gosh. True or false? Decreasing the sample size will make the margin of error a smaller value. So decreasing the sample size will make the margin of error a smaller value. Sometimes I'm afraid I put in the wrong answers. So think what happens if you make the sample size larger. What would happen as you make your interval? And we'll look at this mathematically here in just a second. Decreasing a smaller sample. I'm so afraid. The answer is false. Nice. We still had some wrong answers, but it's all right. So I want you to think this over. If you were to take a small sample, would you be more or less uncertain? If you took a very small sample, not after this. We're going to do a huge one on Monday. I did the 320 Kahoot middle of the week this time. If you took a small sample, would you have more uncertainty or less uncertainty? Nothing to do with confidence here. But if you took a very small sample, would you think it'd make a wide interval or a very tight one like this? If you took a very small sample, you'd be more uncertain exactly. Because look at where this n is at. As n goes to infinity, what does this equation go to? As n goes to infinity, as n here goes to infinity, what would happen to this equation? It would get wetter and wetter and wetter and just kind of go towards this value. As n goes higher and higher and higher, because it's in the denominator, that part of the equation is going to get wetter. It's going to go towards 0. Does that make sense? As n gets larger, because it's getting larger, if you did something like, if you only had here 1, then this would be rather large. But as you make this bigger and bigger and bigger, you're dividing by it. So it's making the interval smaller. Does that make sense, everybody? So if you have a larger sample size, it equates to a smaller margin of error. Because everything right here is the margin of error. And this right here is the center of the interval, which is the sample proportion. And so as we get larger and larger and larger samples, we get a smaller and smaller interval. Is there a larger potential for a abnormal nail in a larger sample, or does that matter? So if you have odd data, so with the proportion, it won't matter, but with the mean, the shape of the distribution will matter. So when you do the sample proportion, because it is binomial, either it happens or it doesn't happen, it actually deals with, and I can show this visually, 2 seconds right here, I'll show you. And let's go here to binomial applet Iowa. This is one of my favorite things. So as long as we pass the success failure condition, it will be normally distributed. Let's put in here 10. There we go. And then we'll put in here something like 10. If you notice, this does not look normal. But if we get here enough observations that it is normal, how does the distribution look when we get enough observations? We'll go back to 100. If we get enough observations that we pass the success failure condition, the distribution will start to look what? And this is why we must pass. I broke it. This is why we must pass the success failure condition, because with enough successes and failures, the distribution will follow the what curve. With enough successes and failures, the distribution follows the what curve. And this is why we pass the condition, so that it's normally distributed. But if we don't have enough successes and failures, because right here you expect how many successes? How many successes do you expect here, which means you don't pass the condition? You only expect one success. That's the expected amount of successes right there. And you only have one. And does this look normal? Do you think you should make confidence intervals with this sort of distribution right here? Because we want to do the 68, 95, 99.7 rule. And if we have 10 successes, it is normal such that we can do it. And then if you only have a few successes, it's kind of skewed. And if you have even fewer, it's even more skewed till you see it just becomes a very kind of mess of a distribution. And this is actually a distribution right here with how many expected successes you would have with 1 in 1,000 with 100 trials. So this right here would not be able to use the normal, and something like this can very much use the normal, and we can do the 68, 95, 99.7 to make confidence rolls. So really great question right there, Andrew. Excellent, excellent work. Kind of big things to think about, like does the shape of the distribution matter? And that's actually what we're doing with random 10% success failure. By doing that, we know it's normal, and we can do it. Yeah, let's do this. Who's going to win? Power Rabbit. I never lost faith, Power Rabbit. I never lost faith. Captain Seal, you're no match for Power Rabbit. This is a neck and neck game. There's barely 150 points between everyone on the leaderboard. Good luck, everyone. Try to take down Power Rabbit, but it's not going to happen. With question number 7, true or false? With a sample size of 300 and a p-hat of 3%, the success failure condition is met. It's like I said this question earlier. It's like I gave this one away. It's like I was making sure you know how to do this one. Sometimes there's some hints between questions. So when we try to figure out, oh no. I won't be able to do this soon later. No. How do we solve this? How do we solve this again? Help everyone out, because maybe there's a sequel question coming up here in a second. How do we solve this? What do we do? Exactly. And that needs to be greater than what then? There needs to be at least how many? Because that's not greater than that. Exactly. Exactly. And that's only 9. There needs to be at least 10. So we're going to get a redo here. I know it's a crazy game today. Everyone, show up on Monday. Show up on Monday. We're going to have a huge Kahoot. We're having a public class on Monday. But tell everyone in group me's or Discords. I mean, I'm on the Discord, but if you're in a group me, be like, hey, Monday, huge Kahoot, big prizes, $40 first prize, $20 second prize, $10 third prize. Did I say right? 40, 20, 10. So 2010, much better than 2020. So show up on Monday, crazy huge game. I don't think we'll crash or anything, but crazy huge game. So let's make Monday. Let's have like 300 people playing. Let's do it. Let's have a crazy huge game. So you're going to have a redo of this. Get ready. Does everyone see it's n times p hat? And then you'd actually have to check n times q hat too. But let's see who's in the lead now. Power Rabbit, no. Is that you, Tyler? I think you might say it was you. Funny Penguin, you're cool. I'll be okay if Funny Penguin wins. Let's see this. Who's going to win next? With a sample size of 30 and a p-hat of 50%, the success failure condition is met. Work it out. Solve it. How do you pass the success failure condition? You need at least 10 successes, at least 10 failures. So do we have at least 10 successes? Do we have at least 10 failures? Do we? Do the math real quick. 50% of 30 is 15. And then 50% of 30 is 15. Is 15 greater than 10? Yes. Is 15 greater than 10? Yes. That means, please, I don't want to see more than 3 people miss this. Ah, love it. I love it. I love it. I am proud. I am proud. That is awesome. Congratulations. Great job. That's why I do a repeat question sometimes. I want to make sure people kind of get a little more practice on it, trying to optimize how we do Kahoot. But it's like, okay, I know how to check the success failure condition right now. I know how to check to see if there's at least 10 successes, at least 10 failures. And this is for confidence intervals for the true proportion. If it was for sampling distributions of the sample proportion, it would be NP, NQ. That's because you know the truth. But amazing work. Who's going to be in the lead with this crazy shakeup? Funny Penguin, I can't bet on you and then you lose. Don't let that happen, Funny Penguin. Don't let that happen. Let's see who wins with the next question. We got 2 more to go. Compute the margin of error for the following confidence interval. Compute the margin of error. There's a repeat one after this one too. This is where I see people have trouble. Things like this are on the test. Compute the margin of error. So first we need to define what the margin of error is. If you think about a margin of error, it looks like this. So here's your whole interval. This is the whole interval. Like if I tell you lunch is going to cost between $10 to $20, so it's going to be between 10 to 20, then you'd estimate it would cost 15 plus or minus 5. I knew it. I knew this would trick people. Don't worry. I expect this is where questions I've seen people miss. So I was thinking at the end of this, I was like, I know people miss this. Can anyone explain conceptually what the margin of error is? It's what of the interval. Margin of error is what of the interval. Think what I'm trying to show you right here. The margin of error is what of the interval. Like here's a margin of error. Here's a margin of error. Here's the whole interval. The margin of error would be what? Well, the center is the estimate, but this is the whole interval. And the margin of error would be what of the interval? What of the whole length of the interval? Like if you have a whole interval like this, the margin of error is what of the whole interval. It's hard to make it show up like that. There we go. Here's the whole interval from here to here. And here, boom, right there, Ashna right there. The margin of error is half the length of the interval. It's 1/2 the length of the interval. So if you figure out the length of the interval and then divide by 2, so it's going to be upper minus lower, which is the length, divide by 2. Mallory, good job. 1,000 points, Mallory. Big number minus small number divide by 2. Exactly. Like how far are the numbers apart? And then divide that distance by 2. So when you do big number minus small number, you just find the distance. And don't worry if you reverse the numbers because you'll just get a negative number. I'm thinking for the next one because I did make the next one a little bit trickier. But I want to see everyone do great on the next one. I don't want you to think about formulas for the next one. So here's the hint to get the last question. Don't think about formulas. I want you to remember in your head that the margin of error is half the length of the interval. Then I want you to look at the interval, figure out how long it is, and then I want you to figure out how half the length of it. So let's see some awesome answers right here. You already know what the last question's about. It's Funny Penguin. No, you got to be quick, Funny Penguin. This is, if I was in fifth or fourth place right here, I'd be like, I got to be quick. I mean, I might just be like, boom. Oh, no, I shouldn't say that. Now people are going to get it wrong. There's got to be some gamesmanship on the last one right here. Who's going to win on the last question? Let's find out. Compute the margin of error for the following interval, -5 to 15. We're playing Mario for this. Let's do it. Where's Mario at? It's like silence in the chat right now. Ooh, who's going to win? Nice job. So many people got it right. Oh, it's classic Mario right there. Classic Mario. So the one person might have clicked really quick because I said, click quick, click. So half the length of this interval. Does everyone understand pretty well how to get the margin of error now? We got way better answers on this one. Margin of error is half the length of the interval. So just take 1/2 the length of the interval. I should have put, yeah, I did put 20 on here. Maybe I should have also put 5, not -5. No, someone guessed it. Sorry if you guessed that. Who's going to win? Who gets the $20 Amazon gift card? Let's find out right here. Creative Dragon. I think you were there at the start, weren't you? Lovely Ostrich. Did someone get 10 out of 10? No one got 10 out of 10 today. Awesome, Samantha. Great job. Captain Seal won. Please email me if you won. And I think everyone's gotten it. Funny Penguin. Great job. Everyone's been getting their Amazon gift cards. Definitely let me know. One person, I had to make sure it's like I didn't send it and they reminded me, but please tell me that you get it. Please send it. Email me via the email address you want me to send it to. And then I'll email you back. Well, I usually email back and say, is this one you want me to send it to? Just want to make sure before I send it to an email address. And they're like, I never got it. I'm like, I send it to that email address that you sent it to. But great job. Well, I got 9 out of 10. That's awesome. No, Andrew, that's still awesome. Because these are designed around the Canvas content questions. So if you're getting 9 out of 10, and this is, like a game show timed thing, you're getting ready for exam 2. You're on track. If you're getting 9 out of 10, then you're studied up. You understand the material pretty well. So King Bowser has higher standards. I know. If someone has just gotten 10 out of 10, how does the bonus work? I thought there was a bonus if you're on a streak. Is there no streak bonus? Or maybe they took that away because then you can't win if you're behind. What are some last questions? Does anyone else have any last questions? Other questions? You'll breathe fire on the test. Do you play Bowser in Smash? For Smash, do you play Bowser? You'll have to tell us if Smash you play Bowser. Let's see. If you have any other questions, let me know. Really great Kahoot today. Excellent work, everybody. It's been one heck of a semester. Test coming up. Test opens up on Tuesday. So let's write this down right here. I missed the Kahoot music already. What if there's a streaming? Just go to Kahoot music. So test starts Tuesday night at 7 p.m. I think they might have extended to 6 p.m. So I think I'll double check the emails. I'll double check. Test closes Wednesday night at 9 p.m. So I don't really play Smash. Sadly, my apartment mate's main is Bowser, though. Yep. I thought all them would have changed the conference role. Oh, which ones? Meta Knight? Yeah, from Kirby, right? Meta Knight's from Kirby. He's the one who's like in the air, like slashing about. He's quick. If someone's playing Meta Knight, I'm like, oh, I might try to edge guard them. I mean, you edge guard everybody, so that's how you play. I still understand the what changes the conference role question. So when we do that, let's talk about that right here. Let me put this down right here. We're doing the huge mega Kahoot. So class on Monday, public stream, and then 5 p.m. No, it's 6 p.m. your guys' time, right? 6 p.m. So this will be at 4:30 p.m. and then mega Kahoot at 6 p.m. So is the next review? It'll be on Monday. It'll be the public class on Monday. Does that make sense, Harrison, right there? So I'll make sure I'll remind everybody via link. It's gonna be a public class. Can you put the link for your website with the review materials? Yeah, of course, Samantha, of course. And then we got a question here too. Great questions, everybody. Let me drop that on here. I'll put straight to the review material for the exam. I made this website a few years back. Here you go. There you go, Samantha. And so Victoria was asking, what changed the conference role? So everything. Have a good weekend, Dan. Good seeing you here. I swear. Oh, you know why I think it does that? Because that's the first pen. Oh. Can I do that? Well, I'll fix that later. So plus or minus z p hat q hat over n square root. So the only thing that changes the level of confidence here is what? Now everything here changes the confidence interval, but the only thing that changes the level of confidence is the what? The only thing that changes the level of confidence is the what? Level of confidence is 100% controlled by this. This is the only thing that controls the level of confidence. So how confident you are is only controlled by this, the z-score. And so the margin of error is more directly controlled by these two. The margin of error is more directly controlled by these two. It is true that these will make the widest margin of errors if they're 0.5, but p hat and q hat are not really something you control for. You can pick your level of confidence, and you could always take a larger sample. So it is true that all of those will control the margin of error to some extent, but more explicitly, the sample size, if it gets larger, will make the margin of error smaller, and if the z gets larger, it'll make the margin of error bigger. So the way that these are connected, that if z gets larger, the margin of error gets bigger, so bigger ME when z gets bigger, and if n gets bigger, ME goes down. So the sample size is connected to the larger the sample size, the smaller the margin of error, and the z is connected, the more confident you are, the larger margin of error. Now, these right here, it's widest at, which is kind of a bigger thing, widest at 0.50. So when you have both of those at 0.50, that's the widest interval, but you don't really control for that. You don't really say, like, let's get a p hat of this, because you're not controlling what the sample is. You can control how much you sample, and you can pick a certain confidence level. Hey, what's up, Colin? We just finished Torch Fund presentations. I want to say, hey, I hope the Torch Fund presentations went well. Is that one of the ones you have to apply for and you maybe win a Torch Fund? There's so many great opportunities. It sounds like it has them. No, it sounds like a UT thing. It was Torch Fund, because I know they've got the Boyd Center stuff. 3 million in assets. That's awesome. Because I know the Boyd innovation grants they do. I think those are. I think my sister might have won one of those. But so many great opportunities. That's one of the things. Is UT's always looking at ways to help out students. There's a lot of great opportunities. Ask around, talk to people. There's a bunch of ways to get involved, and there's a bunch of ways, even during this crazy time. I hope everyone's finding some community. That's one of the hardest things. I'm all the way over here in Texas, but I've got to do some presentations for the honors groups. What else have I done? I haven't done anything too much lately. I get to still teach and everything like that, but there's a lot of great opportunities. So please keep helping each other out. Please keep reaching out. Swing by the chat. So good to see you, Colin, right there. What other questions are there? Let me know what you're wondering about. If you have questions, let me know. Great job during the Kahoot today, everybody. Stay positive, stay strong, drink water all day. Take some water here. So because you have to decide what the z-score is, that is what you can change the confidence, but you can't decide. The only ones you really don't decide are p hat and q hat. You can decide your sample size, but your sample size is, you might do a study where you collect 200 sample, and then it's kind of, you've got it at 200. And then you could choose the confidence afterwards. The one you're in the most control of is your confidence level, because that's just pure arbitrary choice. Now, most people do choose a 95% confidence interval. The thing you're in second most control of would be your sample size, but that's probably going to be decided on after you complete your study. The thing you're in the least control of would be your p hat and q hat. You can't really decide what your p hat and q hat are going to be. You can't say, I want to take a sample of this. You just kind of have this sample. So you don't really decide your sample. Does that make sense, Victoria? I think everything's... So Z is what you're in most control, because that literally is your percent confidence, and you can choose 95, 90, 99, 98. And then awesome, Victoria, great work. And then N is what you're second most in control of. And if you make your sample size larger, you'll make your margin of error smaller, also your standard error smaller. Because everything right here, this right here is literally just the standard error. So this is, I knew it wasn't on it. This is just the standard error of P hat, the uncertainty in the estimate of the sample proportion. So that is just our standard error of P hat right here. And if we make a larger sample size, it'll decrease the standard error. So we don't usually write it like this, but the confidence interval can be written this way. Excellent job, everybody. Great work. I think with that, if you have another question, let me know. But we're getting so ready for the test. I think we're doing a great job. We'll have some big reviews on Monday. Let me know. We might do some additional stuff. You're welcome, Alexandra. Great job. I will see everybody later. Have a great weekend. Enjoy yourself. Bye for now. Bye.